Miss Lee's Chemistry Academy. Lab 2, Mass Determination by Gravimetric Analysis. Investigation. In this lab, you'll be given a 1 gram sample of a solid mixture containing sodium carbonate and copper sulfate. You will need to design a procedure to separate the mixture so that you can determine the mass percent of copper sulfate in the mixture by gravimetric analysis. Gravimetric analysis. To understand this lab and create a procedure, you must understand gravimetric analysis, which is a quantitative analytical technique involving the addition of a reagent that reacts with an analyte to form an insoluble compound through a precipitate reaction. The created precipitate can be isolated through filtration and be dried and masked. The analyte that reacted with the reagent can have its mass calculated and the mass of the precipitate by stoichiometry. Chemistry Principles 1. A key understanding that should be known is the solubility rules pertaining to sodium carbonate and copper sulfate. When these two solids are dissolved in water, they will form a solid, copper carbonate, which is illustrated in the equation below. Chemistry Principles 2. Another key understanding is that dilute hydrochloric acid can be added to the created solution in excess, and it will react with the copper carbonate and any remaining carbonate ions to form carbon dioxide gas, which is shown in the equation below. Chemistry Principle 3. Lastly, it is important to understand that aqueous barium chloride will react with the sulfate ions in the solution and create a solid barium sulfate. This can be extracted from the liquid through suction filtration and then dried and masked. The reaction between the barium chloride and barium sulfate is shown below. Procedure. To begin this experiment, you must first dissolve the masked 1 gram sample of the mixture in a beaker filled with 100 milliliters of distilled water. A solid will form which will make the solution look cloudy. This solid is the copper sulfate. Step 2. Then you will add approximately 12 milliliters or more of 2 molar hydrochloric acid solution to the beaker containing the previously made solution. The addition of the hydrochloric acid will react with the copper carbonate and will dissolve all of the solid and react with any remaining carbonate ions. Continue to add the hydrochloric acid until the production of bubbles stop. To calculate the approximate amount of hydrochloric acid to add to the solution of the mixture, you must assume that the mixture is 100% sodium carbonate. This calculation is shown below. Step 3. After the precipitate has been dissociated, add 10 milliliters of 1 molar barium chloride solution in excess to precipitate out all the sulfate ions in the beaker as barium sulfate. To calculate the amount of barium chloride needed, you must again assume that the mixture is 100% copper sulfate to make sure that the barium chloride is in excess. Step 4. Once the barium chloride has been added and a precipitate has formed, filter out the barium sulfate through suction filtration. Suction filtration is just a faster method of filtration. But before you begin the filtration, mask the piece of filter paper you are using because the data will be needed later. Step 5. Lastly, once all the solid has been collected, dry the solid and the pre-masked filter paper in an oven for a few hours or until completely dry. Once completely dry, mask the filter paper and the barium sulfate. Data. This slide shows the important measurements needed when doing our calculations. The mass of the sample mixture, filter paper before filtration, and dried filter paper and the barium sulfate solid. Computation. To find the mass of barium solid, you must first take the mass of the dried filter paper and the barium solid and minus the filter paper's mass. Once you have the barium sulfate's mass, you divide it by its molar mass, use mole ratios to go to copper sulfate, and then multiply it by the molar mass of copper sulfate to find the grams of copper sulfate in the original mixture. Then, to find the mass of copper sulfate in the original mixture, you divide the copper sulfate's mass by the overall mass and multiply it by 100. Then, to find the mass percent, you take the absolute value of the accepted mass percent minus the experimental mass percent, divided by the actual mass percent, and then multiply it by 100. Error analysis. Some points of error could have included 1. If the filter paper is not completely dry when masked, with the barium sulfate precipitate, the mass of barium sulfate will appear to be greater. This will result in a higher mass percent of copper sulfate calculated. 2. If the barium sulfate precipitate is not washed thoroughly to remove all impurities when being filtered, the mass of the barium sulfate will appear to be greater. This will result in a higher mass percent of copper sulfate calculated. 3. If not all of the carbonate ions have reacted completely with the hydrochloric acid, barium carbonate solid will form and add to the mass of the barium sulfate precipitate. The mass percent of copper sulfate calculated will be higher. If not all the sulfate ions have been precipitated as barium sulfate, the smaller mass of barium sulfate will result in a lower mass percent of copper sulfate calculated.